Hello, this is assignment 3 for Conf 361, A-star algorithm path planning. For this algorithm, we were tasked with implementing the A-star path planning algorithm to find ways to travel between two cities in the Fraser Valley. This is the list of cities that was given to us, and what I ended up doing was using the Google Maps API to get the distances between each city to create a fully connected graph. Here is just saving and loading of the graph. This is the creation of the heuristic that is used for this project. As you can see, the heuristic is simply a copy of the graph with a random number from 5 to 10 subtracted from it. This is a function that prunes the graph. I will talk more about this later. And this is the main algorithm. So here you can see all the inputs, start, end, graph, heuristic, the algorithm, and whether the graph should be pruned. This is a very standard A-star algorithm, right? So we create a heap-based queue, or heap-based priority queue, sorry, to perform breadth first search based on the FN value of each of the cities. Here we pop the one with the, I guess, highest priority, lowest FN. And then we look at its neighbors. And you can see that depending on whether the algorithm is a star or not, here as well, our FN will either just be G, which would make the algorithm Dijkstra's algorithm, or we will also consider the heuristic, which makes it a star. And then once the path is found, it is returned. And this is the pathfinder function, which essentially just gets the user to input all their desired values and then calls solve. So we can run an example here. We will say we want to travel from Vancouver to Hope. And we want to use the A-star algorithm. And we don't want to prune the graph, just for an example. It will return that the fastest or the cheapest path from Vancouver to Hope is directly from Vancouver to Hope, which makes sense because Google Maps already finds the optimal path from city to city. This is where there's a bit of confusion because the assignment documentation states that our graph should not be fully connected, while I spoke with the instructor in person, and the instructor stated that the graph should be fully connected. So to that end, if we do not prune the graph, then our graph is fully connected, and then for any two cities, the fastest path is going straight from the starting city to the destination. If we wanted the graph to be not fully connected, we can do the same example, but we're doing a star. But this time we will prune the graph, and what this does is this removes any connection that is over 60 kilometers long. So now you will see that our path is now Vancouver to Burnaby to Abbotsford to Chilliwack to Hope, showing that the A-star algorithm does work. Yeah, and the kilometers can be reduced further down if we want even shorter paths between the cities. And that's it. So I implemented Dijkstra's algorithm. I did not implement the Grassfire algorithm, although for Grassfire, once again, it would all be the same. It would just be the fastest way is to go directly from the start to the end. And I have not implemented a function to make all the heuristics consistent.